Next talk is by Barbara Cohen on the Lunar Flashlight small sat mission. Barbara?
Hi, everyone. Thanks for having me. I think it's been wonderful to hear about all the ideas people have for a coordinated lunar resource campaign. But we have a lunar resource campaign. It's already starting. And so I think we need to make sure to include what agencies are already investing in and what they already think the thrust of our resource campaign is as we develop the future, and Lunar Flashlight is one of those missions. So Lunar Flashlight is set to launch this December. Maybe it's going to be on the Intuitive Machines CLIPS launch. The current launch date is December 27th. We'll see how that holds. We used to be on the SLS. I think many of you remember that. We missed our SLS integration, and so now we're on that Intuitive Machines launch. And we are illuminating the South Pole using an active laser illumination system designed and tuned to be able to look at water, ice, frost in polar shadowed regions where normal sunlight illumination doesn't get. So can I have the next slide? So we are designed to understand these lunar resources. You've heard the science. Orbital maps of water have some mutual inconsistencies that we're struggling to understand scientifically so that we can correlate all those properties with geologic processes that we understand and can apply them to places where we don't actually go. So all PSRs aren't cold traps, all core traps don't harbor volatiles, and volatiles doesn't necessarily mean ice. Lunar Flashlight is looking at a very small piece of this. We're looking at lunar surface water frost, but I want you to keep in mind that Lunar Flashlight is a technology development mission run by STMD, and we're specifically demonstrating green propellant technology and some new avionics and telecom technologies. And so our measurements are capabilities driven. Next slide, please. So our measurements themselves are to reflect light down from our laser beams into places where we think there is water ice, especially in polar shadowed regions where our lasers are tuned. You can see on the spectrum on the right that you've seen before, they're tuned to the water ice absorption features and the continuum there. And as we go along, we shoot our laser beam down and collect that light and measure the band depths to get our water ice abundances. And next slide, please. We're going to do this across the moon in something like 10 to 13 orbits. We're not 100% sure yet how much our fuel is going to allow us, but it's something like that, something like once every week or every 5 days. We're in this near rectilinear halo orbit. And so we'll cross the South Polar region, maybe not exactly polar, but somewhere down there. Statistically speaking, there's lots of PSRs. You can see them there outlined in orange, and there's some of the higher priority targets that we've identified to corroborate some of the measurements that will be being made on the ground. And as Noah said, being there at the time of LRO is going to help us coordinate these as well. So last slide, Lunar Flashlight is coming soon. These kinds of measurements may not be the be-all end-all of what you really want, but if we make a lot of them, including Lunar Ice Cube, LunaMap, Trailblazer that you're going to hear about next, Viper, all of these missions coordinated with LRO and coordinated with each other enables predictions of other deposits and informs us on what recovery paths we need to follow. So our anticipated performance, just to set expectations, we think we're going to be able to measure water ice frost at about 4 weight percent abundance, a long track about 10 kilometers. And we'll see how we do later this year. Thanks.